The first conic I would like to discuss is the circle. I use circles in both my S and my Y. The S is made up of 4 circles, 2 circles sharing a center, and the other 2 sharing a center below it. I use different restrictions on r sine theta and r cosine theta so it would have a smooth connection. The top of the Y is made up of a semicircle. I use restrictions on r sine theta to restrict the graph to the bottom half of the circle. I used a parabola for my A, with a line connecting the edges. I used restrictions on r sine theta to restrict the parabola at the polar axis. I used hyperbolas in my E and my H. A vertically orientated hyperbola replaces the top and bottom lines of a normal E. The r is restricted between the vertical line of the E at r equals secant theta and at r equals 5.5 secant theta. A horizontally orientated hyperbola is used in the H with a line connecting the 2 parts at the center. The r sine theta is restricted at 0 and 7. Finally, I used a horizontally orientated ellipse in my r as the top curve. The r cosine theta is restricted at -4, so it ends at the line r equals -4 secant theta. To derive all equations, I used the rectangular formula of the conic, converted all x's and y's into r cosine theta and r sine theta terms, and used the quadratic formula to simplify. The most difficult part of this project was creating the restrictions for the lines and the circles for my S. The lines were truly a matter of guess and check, where I increased and decreased the restricted value and saw what the graph looked like. The S was difficult because I needed to use both equations I derived from the quadratic formula. When I did so, I could not use the restrictions in the same way because different parts of the circle were being restricted.